then right into it without wasting any more time. So I'm going to be basing a lot of this talk in in this, which is captured by Stefan, who's one of our teammates here at ZenML, which is called "Keep the lint out of your ML pipelines. Use Deepchecks to build and maintain better models." And one of the cool, interesting observations about this entire blog post was how we had to really, with Deepchecks, we had to rethink our entire data validation abstraction. So we had great expectations, we had evidently before, but when we got to Deepchecks, one of the things that we were forced to do in a good way was we had to really redefine our entire logic of data validation to incorporate some of the patterns which are reflected in Deepchecks. And Stefan talks a lot about in this blog post how it's such an innovative way of doing data validation that we had to really rethink it. So I just want to give a shout out to you guys. You did a fantastic job. I think you're approaching it exactly the right way. So I'm going to go into how this works with ZenML. So with ZenML, as everybody knows, we have a lot of people here in the community who already use it. So I'm going to be showing a little notebook. And within this notebook, I'm going to be showing how to use the ZenML and Deepchecks integration. It's a bit of an initialization step with profiles. Not going to go too much into that. And then, as always, straight into looking at stacks. So briefly mentioning what stacks are again, stacks are defining what and how your pipelines run. So in ZenML, there are two major concepts. One is a pipeline, which is your Python code, which is just what happens with the transformation of your data or the training of the model, so on and so forth. And where the pipeline runs and how it runs is actually encapsulated by what we call a stack. And a stack has different components. And one of the components that we would like to talk about today is the data validator component. So you can register data validators independently of a pipeline. So I can list my data validators. I don't have any data validator registered right now. But if I was to run this line, you could see that with the ZenML integration with Deepchecks, we already have a flavor called Deepchecks that I can register. I don't have to give it any parameters. It works quite well without. And I'm also going to be showing MLflow here today just to show off some of the other capabilities of ZenML, but we should really be focusing on the data validator aspect. So I'm registering the data validator. I'm registering my experiment tracker, which is MLflow, another tool, another fantastic tool for a different purpose. And I'm putting them all together in a new stack, which I'm calling local stack. And now you can see, if I rerun the other step, you can see that this is my data validator. I have one. And if I do my stack list again, I would be seeing another stack. Local stack. Here it is. So everything right now is local. So you, as always with ZenML, we encourage you to start locally and build out towards the cloud. So how does that look like in a visual way? That's how it is. So you have pipeline at the top, right? You can build whatever pipeline you want, a data pipeline, a training pipeline, a deployment pipeline, and they talk to what we call a stack. And the stack consists of things like experiment tracker, artifact store, orchestrator, and data validation. And here we're going to be using Deepchecks for a local pipeline run. So let's build our pipeline now that we have our stack, right? So pipeline is going to be very simple. It's going to be using the iris dataset, just for exemplary purposes. But you can use whatever you want. As always, I'm going to be returning two datasets from the first step, and I'm going to be splitting them into train and test. Very classic data loading step. And then here's where the first magic of the integration comes. So with ZenML, now you have this standard step. So anytime you import a step or a component from within ZenML, we call it a standard step, right? So here, the ZenML integrations, Deepchecks integrations module, which you just installed before, has given you two things. One is the configuration, and one is the actual step. So unlike this step, which is a non-standard step, it's something that I defined, I can actually literally import my step, give it a name, and give it a config, and I have my step definition here. And in the blog post, you'll see that there are 4 different types of steps that we have integrated with Deepchecks. And these are all corresponding to the Deepchecks, their own reports that they have, the suites that they have already. So you have the data integrity report, you have the data drift report, model validation report, the model drift report. So for all of these, and we can expand this as we get more reports, you can import the steps to do what you want to do. I'm going to be using 2 of these today, particularly the model drift one and the data integrity one. So really fantastic reports that are infinitely customizable. And of course, if you wanted, you could also use whatever report you wanted. So you could customize your suite and add more checks as you wished and just reference them in your step here, and we would still work. So that's the user level experience with ZenML. All right. Next, what I'm going to do is I'm going to be creating a trainer, and we're just going to be fitting a random forest to the Irish data set. Here you see the little resource configuration. This is something not relevant for today, but for those of you who don't know, we do allow you to configure your step resources. So you can give the number of CPUs, the memory, and we have enabled our ML flow here because it's in our stack. So we don't need to set up ML flow at all. We can just use it straight within our step, and it will log everything. Right. Let's keep going. Again, this is just initializing another deep check step. And how do we put all of this together? We put all of this together in a pipeline, which I'm calling the data validation pipeline. And here I'm, oops, sorry. Here I'm actually just putting it together in a way that can, sorry, let me just turn this off. In a way that I can just say, okay, this is the first step, data loader. Then we have the data validator, and just like a Keras model, you're basically defining the inputs and outputs, so the DAG in this simple function. And by plugging the DAG with the concrete functions that we just defined above, we can create a run. So everybody who knows NML, and I'm assuming most of you in the call have already done this, so I'm just going to run this pipeline. Let's do it. All right, so as you can see, it has picked up that we're using the local stack, so everything is running locally. First step was very fast. Second step did something with the drift detection, then the data validation, then it started training, and here we used ML flow, and then it had a drift detector for the model afterwards as well. And we even have a model validator. Okay, so now that's done. So this pipeline ran in about 15 seconds. That's quite fast because everything was running locally on our toy data set. So how can we access the results? So simple as before, we can use our repository object in ZenML to get the pipeline, return the pipeline. I'm using that function to get my latest pipeline. So let's do that. And here I'm getting the last run from that pipeline. So this object is basically a pipeline run view. So you can have a view into the pipeline that ran. And I can, of course, see my steps and all the outputs of the step. If I wanted, I could also read a particular step in. So for example, if I wanted to read in my reference data set, I could. So that's quite easy. But generally speaking, I mean, this is all basic ZenML stuff. What's very interesting from this demo's perspective is that I have within the Deepchecks visualization, integration, we have a Deepchecks visualizer that is built in. So if I get my 2 data validator and model validator steps, I can literally pass those steps right into the Deepchecks visualizer and visualize the report. So you can see right here that the data validator, this is the same as any report. I mean, you can use Deepchecks for this as well, and this comes straight from Deepchecks. It's nothing that ZenML does. But what ZenML does is it sets this up and tracks it for you. So you can see all my reports here. Everything has passed. Some have not passed. So the feature label correlation. This is for the. You can see the report is called the same as the pipeline run name. which is very useful for lineage purposes. And I can actually also get the other step and pass that in, and then it's the same one, sorry, it's to the model validator. I can also see my model validator report, which is a bit different, and you can see other things here. So this is all done for you with ZenML, and in a local case, it already gives you value because we're already versioning your reports. So if I visualize the lineage of my DAG, you can see that I had all these steps. And in the model validator, for example, I produced an output which is stored and versioned in the artifact store, which is local to me right now. And I can always access that, even if I'm working super locally and not really going to the cloud, right? So that's already a high value thing, because I think if you track these manually, it's a bit hard. Right, but that's not the only thing. Just as a side note, by the way, of course, we also have MLflow here. So we're also putting everything in MLflow, but that's not the purpose of the meetup. So let's go over to something a bit cooler than running locally. So obviously, if you have something like Deepchecks, you're going to want to run this in training, in experimentation, but also in production, right? So you might want to make some actions on a Deepchecks report, like if it passes, then deploy the model. If it doesn't pass, then don't deploy the model, stuff like that. So in order to do that, this is, of course, one of the values of ZenML, is you can just create another stack, right? So right now I was using the local stack with the local orchestrator, and I have another stack here, which I've just printed out. It's the Vertex stack, and the Vertex stacks is saying, okay, don't store the artifacts locally, store them in GCP in a bucket. So version my reports in a bucket. I'm also adding a container registry. I'm adding all sorts of things. And in particular, I think this is something you might be, you might want to know about, the orchestrator. So I don't want to orchestrate this locally, but I want to actually orchestrate this in a Vertex pipeline setting. Vertex is the GCP. Vertex pipelines is the managed Kubeflow, if people know Kubeflow, on GCP. So it's a special service that GCP provides that a lot of our users love to use. And why wouldn't they? It's very, very production-oriented system. It gives you a lot of resource management stuff that is very managed for you. So you might want to just run this pipeline on the cloud like that. And of course, my experiment tracker is not local anymore, so I'm going to use this deployed MLflow, which is behind a password and username. Okay, so I have my cloud stack in a vertex.yaml file. Because I'm not using a centralized ZenML instance, more on that later, I have to import this in a YAML file. So that is also quite easy. I just do a stack import, and then it registers all the stack components, boom, 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 and puts everything in a nice little stack. And now I should have another stack, which is active. Not active yet, but if I set it to be active, then you can see my list will switch over to making the cloud stack active. And this is very cool because without now changing any of my code, I can run the same code and run this pipeline on Vertex. Before we do that, there's one minor maintenance thing that I have to do. So this is something ZenML specific because we have a lot of users here of ZenML. I'll just mention this few seconds. So this is where you register your secret. This is a sort of a little annoying step that you have to do because you're using a metadata store that is hosted on the cloud. So you have to connect your orchestrator to that. So we need to pass that traffic through SSL. And because that's the case, you need to register a secrets manager and pass in a secret. This, by the way, in the next releases of ZenML will be a lot easier. But for now, I've just passed in my certificates, which I generated on Vertex and registered my secret. And ZenML can already play with those. All right, so I have my new stack. I have my secrets registered. Hopefully, everything is set up on the infrastructure side. I can now run my pipeline again. So in this case, you can't run it straight from the notebook. you have to run it from a script because of course, you're running in the cloud. So ZenML cannot take your notebook and convert it into a cloud Docker image. So you need to put your steps outside in a script, but they can be the same steps. So you don't need to change anything. All I'm doing here is I'm just using a script to take the same pipeline that we saw and do the same command .run that I did in this notebook not too long ago when I did the first run of this pipeline, like here. So that's all I'm doing. All right, so let's run it. Python under py. And here you'll see something really interesting happen. So now ZenML is not going to run on the local stack. It actually has picked up that there is a non-local stack, so like a cloud stack, which we're using, which has a container registry. It has an artifact store which is on the cloud. It is using all that information, like this meta information, and combining that into a Docker image where you install Deepchecks, you install MLflow and all that. And then after that, it pushes it into the container registry and then deploys, because it knows it's using Vertex, it deploys a Vertex pipelines job, which I can then see in the cloud if I'm using GCP right here. Of course, you can do this in AWS, you can do this in Azure, so on and so forth. But for now, I'm using GCP because I prefer it personally. But you can see that now the same pipeline that I just ran is Dockerized and running in a reproducible manner in a production setting in my production orchestrator, which happens to be, Vertex. This will take a bit. So I already took the liberty of running this in 21st of September, so not too long ago. And you can see this is how it will look like at the end. So all the steps will have run successfully, but this time in the cloud. As all my code has been transported to the cloud, the same code. And now I can actually get the latest pipeline and maybe get the run before this. And you can see this is my, latest, meaning if I had the patience, I could wait to get the latest one, but the latest one is still in progress. This one has completed. And then I have, the cool thing is I have the same experience as I always did. So I can literally get my step. And this time you can see my data analysis artifact, which used to be in local, is now in my bucket, right? And I can pass it to my Deepchecks visualizer, and I have the exact same experience, exactly the same. Rather than versioning it in my local file system, I'm actually versioning this in the bucket, and I have all the things that I need here. So I can do that many times, or my team members can do that, and I can produce many reports, and I can take action because the way ZenML works is you can pass these components around within the steps and actually parse them. So this is where the Deepchecks team helped a lot. They actually made it easy to serialize and deserialize these things. So we were able to use that to pass, for example, whether it's successful or not, right? So you can always see whether you can go deep into those sweet results and really find out, any sort of mechanism that you might need for a production setting. So one thing that we used to do in production at my previous startup is we used to pass it through a whole bunch of checks. If all the checks passed, then we deployed the model. And this is also what you could do now here with the Deepchecks integration. Right, so this is running. We can wait for this to end or just, I guess we could also just end it here. I will conclude with maybe some links. So please, if you want to have an in-depth look of how we did this, you can follow this blog, Deepchecks in ZenML. We also have detailed docs about data validators in ZenML and particularly Deepchecks here in the docs. And these are really cool because we go into very detailed about what things we support, like computer vision or tabular, and all the cool things that Deepchecks already has. Just exposing that in a nice way to ZenML users is one of the main things we wanted to do. And it's a very deep integration, so yeah, that's it. That's all I wanted to show you today, and I hope you like it. And if you try it out, then let us know on the Slack or on GitHub. Thank you very much. Open to questions, so if you have any, just pop them over right now, and I can try to answer. I saw some movement, maybe like Simon or Clément.
Yeah, thanks, Hamza. It was really interesting. Looks like a great integration. I was wondering, you mentioned that this would be a pipeline that you could run before you run a deployment.
Sure.
Wondering, where would you see that in the context of ZenML in a production setting? So would this just be like the final part of the pipeline you would run, or is this something that you see at like as part of a CI/CD setup?
So in a lot of ways, the ZenML pipeline is CI/CD, right? So in that sense, I imagine this to be part of a production ZenML stack and a production ZenML flow. So if you have a pipeline that at the end deploys a model, or at least trains a model, right? Then you might want to preface that or prefix these steps before. Sometimes training is expensive. You don't want to do that if the data is not high quality, right? You don't want to waste those resources. So you could have a conditional step before. Sorry, excuse me.
Awesome, thanks.
Yeah, so you could have a conditional step before that actually decides whether the next step will run or not.
All right, makes sense. Thank you.
Mm-hmm. And then also, of course, I think the Deepchecks folk will help me a bit, but because of the model validation libraries, you can also do this at inference time. So if you're inferring from a model and you produce a data frame of inference results, then you can pass in the step the data frame of inference results and the model, and it will also tell you, it will also give you a report for drift and all those things, right? Nice. Where can we get the Jupyter Notebook? This Jupyter Notebook is made by me an hour ago. So I will try to put it up somewhere in GitHub, but I think it's very similar to the example that we have in GitHub, which I will share with you in a second. So, I mean, we don't show in this example, we don't show the vertex, but you could combine the vertex example with the Deepchecks example and get the exact same result that I did. Nice. We have a couple of minutes left. Any words from the Deepchecks team, which is here today? I just want to thank them again for creating the awesome tool and being here. So, guys, if you want to say something to the community or if you want to plug something, go ahead. I don't know if I should go to share right there or someone else like Aaron.
So thank you very much for this great introduction and including us in your rich set of integrations. We really appreciate it. Maybe Sheer would like to share a little bit more about it.
Yeah, we've been in contact about this for some time, so happy to see this live, and well, I think we'd be happy also. We are also on your Slack community, so people can also feel free to reach out for us to questions, and like you, we also have actively taking issues and feature requests from the community, so we'd be happy to hear any requests. And yeah, I think it was a great introduction.
Excellent. Thank you so much for building it. I think it's much needed in this space, personally. So fantastic job there. Okay, so I'll pass it back. If there are no more questions, ask anytime, of course. Also on the Slack, we're available. But for now, I'll pass it to Dixon. Dixon, maybe you want to say something about the events we have coming up.
All right. So thank you, Hamza, for the demo. So we have 1 more minute left. And before we end it here, I'd like to just share this information that we have. We have an event upcoming next month, and it's a MLOps competition So basically, it's a month-long online competition. You can join the competition. It's there's no fee to joining, and you can just pick a problem of your choice, put them into production ready step in 4 weeks, and we suggest that you take a problem from Kaggle or whichever platform that you find interesting and put it into production step. And there's some attractive prizes as well to be won. And if you're new, don't worry. We also have prizes for most promising entrants. So if you're new to ZenML, don't worry. So we got you covered. And the link will be posted. Just post this one here. The link to join. And if you have any questions, you can also ask us on Slack. And that's the first one. And the second one, just now Hamza was talking about something that we've been working very hard about, and it's the Zen server and the dashboard. So we actually have a launch day coming up on the 5th of October. So everyone here, I'd like to also personally invite you to join our launch event. And the link is also already in the chat. Hamza, do you have anything to add to this?
No. I mean, I think that's it. Please do join for both events, and then we can end. If you have any questions, by the way, you want to chat with me or Dixon or any of the team, I'm around for 5 more minutes. I'll stay in the call, but for the rest of you who have other plans, wish you a best afternoon, evening, wherever you are in the world.
Thank you so much.
Thank you for joining, everybody.
Thank you.
Thank you.
Thank you. Bye-bye.
Bye-bye.
Awesome. Nice. Cool. I don't know if we have only 3 people, I guess, left externally. Samant, Mukesh, Lukman. Hi, guys. We're not recording anymore.
Yeah, hi. So are you providing any MLOps service through ZenML?